this portion is your 4.4 portion, which is solving using the quadratic formula. Most of the concept of this is an Algebra 1 skill. But whether you learned it or not when y'all were in 8th grade is a different story because of COVID. Okay, so we're going to basically look at what our values are. We always want it equal to 0. Okay, so if it's not equal to 0, we're going to make it equal to 0. Then we're going to identify what our values are. So remember that standard form is your ax squared plus bx plus c. So we're going to identify what our a, b, and c are. And then we're also, if you look at this formula, you've got a 4ac. You're multiplying 4 times a times c. So we're going to go ahead and take care of that when we identify our a, b, and c values so that it's less chaos in your work when you're working through the problem. Okay? So once you do that, you're going to just simplify from there, and you're going to solve for x. So if I have x squared minus 7x equals 18, I need it equal to 0, so I'm going to subtract that 18, and it would give me x squared minus 7x minus 18 equals 0. Okay, then I'm going to identify my values. So my a is 1, my b is negative 7, my c is negative 18. So then when I take 4 times a times c, I'm doing 4 times 1 times negative 18, which should give you negative 72. Okay? So our formula is that x equals negative b plus or minus square root of b squared minus 4ac all over 2a. This negative b is just telling you it's the opposite of b. Okay, so if you have a negative, when you plug it into your formula, it's going to turn positive. If you have a positive, when you plug it in, it's going to turn negative. Okay, then b squared, then that minus 4ac is what we just calculated. So I'm going to have x equals. Now I want that x equals all the way down because it is x equals. Then I'm going to have the opposite of b. Well, b is negative 7. So what's the opposite of that? Just 7. Plus or minus the square root of. Now I'm taking b squared. What is negative 7 squared? 49. Now I'm squaring it, so it should always be positive. Okay? Then my formula has a minus. So I'm subtracting a negative 72. So if I'm doing minus a negative, that's really turning into a positive 72. All over 2 times a. Well, what's 2 times 1? 2. Okay, so that makes it a whole lot neater when you're doing your work if you go ahead and calculate your 4ac in advance. Okay, so now we're just going to simplify. I've got 7 plus or minus the square root of 49 plus 72 is going to give you what? 121 all over 2. So the square root of 121 is 11 all over 2. Now what happened when we were completing the square and doing everything else? If you have a perfect square, you end up splitting it. So you're going to do the same thing. You're going to split x equals 7 plus 11 over 2 and x equals 7 minus 11 over 2 and get your two x values. So 7 plus 11 gives you 18, divided by 2 would give you 9, x equals 9. And then 7 minus 11 divided by 2 would give you x equals negative 2. Did y'all go over this in Algebra 1? Some of y'all did, some of them. Okay. Okay. Well, it's okay if not, because all you're doing is plugging into a formula and simplifying. Okay? So this next example, I've got negative 3x squared plus 4x minus 4. The good thing about the quadratic formula is it doesn't matter if your leading coefficient is negative, if it's greater than 1, whatever it is, it's okay. Okay, as long as it's equal to 0, which it is, so we're just going to identify our values. So my A is -3, my B is 4, and my C is -4. So when I do my 4AC, I'm doing 4 times -3 times -4, which would give you 48. Okay, so then I'm going to plug everything into my formula. So I have the opposite of B. B is 4, so I'm going to have a -4 plus or minus the square root of B squared. 4 squared is 16 minus 48. All over 2 times A. 2 times -3 is -6. So then I simplify. -4 plus or minus the square root of what? -32 all over -6. Now the square root of -32 is not a perfect square, but I can simplify it. Now I have a negative under the radical. What do I know I'm going to have to do? Take out your I. I know I'm going to have that. Okay. Now 32, if you need to do your factors, 2 and 16, 2 and 8, 2 and 4, 2 and 2. So square root of 32 simplifies to 4 square root of 2. So I'll have plus or minus 4i square root of 2. Now when you get to this, you need to look at all three numbers right there. You're going to look at the number in front of your plus and minus, the number in front of the radical, and your denominator. Can you simplify all three of those? You can simplify them all by -2, right? Because we've got this negative in the denominator that we don't want. Okay? So it's going to end up being x equals 2 plus or minus 2i square root of 2 all over a positive 3. You're good with that? Okay. So now this third example, we're going to look, it's already equal to 0. So I'm going to identify my values again. So my A is 1, my B is -8, and my C is 16. So 4 times 1 times 16 will give you, so you've got x equals what? 8 plus or minus square root of 64 minus 64 all over 2. So I've got 8 plus or minus square root of 0 over 2. Well, square root of 0 is 0, so x is just equal to 4. Now, when you take the square root of 0 and you're just left with whatever that is divided by, that's your double solution. So when you have the square root of 0 in your quadratic formula, that's going to indicate that you have a double solution. Y'all good? Any questions? Okay. So when you're doing the quadratic formula, you've got the expression b squared minus 4ac under the radical. That value that you get is called the discriminant, okay, which is different from the discriminant when you do matrices. But this discriminant is going to identify and determine the nature and the number of solutions to your equation. Now remember, solutions, everything we're solving for are your x-intercepts. The root solution, zeros, x-intercepts are all the same thing. Okay, so when I say the nature of it, we're talking about real versus imaginary. Okay, so we're going to figure out how many roots do I have? How many solutions do I have? So if that value of the discriminant, b squared minus 4ac, is greater than 0, what type of number is greater than 0? Positive. So if I have a positive value for my discriminant, then I have two real solutions, meaning I have two x-intercepts. Okay? You're going to have to know this, so make sure you're grasping it. When that discriminant is equal to 0, we say it's a double solution because that's only one x-intercept. So in your algebra, we label it ds, but on your graph, you only have one x-intercept. So you would have one real solution. Now, when you have that discriminant less than 0, when it's negative, then you don't have any x-intercepts on your graph. You have two imaginary solutions. Okay, so you're going to be solving for the discriminant and identifying how many and what type of solutions you have. Okay, so if it's positive, two real solutions, equal to 0 is one real solution, less than 0, if it's negative, it's going to be two imaginary solutions. Okay, so that's what our next section is. Find the value of the discriminant, give the number and type of solutions for each equation. So I have x squared minus 6x plus 10 equals 0. So we are evaluating what b squared minus 4ac is equal to. Okay? So, what's my b? Negative 6. What's negative 6 squared? Minus, I'm taking 4 times a times c. Which is, yeah, so I have 36 minus 40, which is negative 4. So, how many and what type of solutions do I have? Two imaginary solutions. Thank you so much. Okay, so now I've got x squared minus 6x plus 9 equals 0. So my b squared happens to be 36 again, minus 4 times my a, which is 1, times my c, which is 9, would be 36, which gives me 0. How many and what type? One real solution. So if you want to plug it in like this and show me that, that's fine. If you want, you at least need to show me what your b squared is and what your 4ac is. Okay? So minimum is this, this, and that. Okay? So now x squared minus 6x plus 8 equals 0. I'm going to take b squared, negative 6 squared gives me 36 again, minus 4 times 1 times 8, 32. So 36 minus 32, 4. So how many and what type? Okay. Y'all hold that thought. Okay. So the next section is where we're going to do the sum and product of roots. So remember, your roots are the same thing as your solutions, which are the same thing as your x-intercepts. Okay? So what we're doing is, if I'm giving you the roots, we're going to figure out how do we write the equation just from those roots. Okay? So the sum means we're doing what? Adding. We're going to add the two roots. Okay? When you add the two roots, whatever you get, the numerator is the opposite of what your b is. Your denominator will be your a. Okay? Product means I'm doing what? Multiplying. when I multiply my two roots and I get my answer, the numerator is my c, my denominator is my a. So they should be divided. If you have fractions, your goal is to make sure the numerator is the same because that's your a. Okay? So remember that standard form is your ax squared plus bx plus c, and we want that equal to 0. Okay? So for this first example, I've got 3/4 for one solution and negative 12/5 for the second solution. So if I'm taking the sum, I'm taking 3/4 plus that negative 12/5. Well, those don't have common denominators. 3/4 would be what? If I needed a common denominator, my common denominator should be 15/20. And then I've got a negative 48/20. And what does that equal to? Negative 33/20. Now we said the sum is the negative b. So if this is negative b, my b is really what? 33. And then my a is 20. Now, if that's simplified, I'm not going to simplify it at first. I want to see what that second answer is going to be when I multiply them, because I want to see what's going to be my denominator. Okay, so sometimes, yes, it could be simplified, but you might not necessarily want to simplify it right here. Okay, so for the product, I'm taking 3/4 and I'm multiplying it by negative 12/5, which gives me what? Negative 36/20. Okay, I've got the same denominators, so I'm going to leave it like that. Okay, my a is 20. That negative 36 is my c. Okay, so if you need to see it listed out, you don't have to write it, but if you need to, a is 20, b, remember negative 33 was the opposite of b, so it's really a positive 33, and c is a negative 36. So then I just plug that into my standard form. So I should have 20x squared plus 33x minus 36 equals 0. You're going to have to know what those are, though, because I'm not going to have that on the test. They're good? Okay. So when I do the next one, I have 7 plus or minus 3i. So that's your 7 plus 3i and 7 minus 3i. Those are my two. It's written as one, but those are two. So when I do the sum, I'm going to have 7 plus 3i plus 7 minus 3i. So 7 plus 3i plus 7 minus 3i just gives me 14. Now, I really want it in fraction form. So that's the same as what? 14/1. So then that 14 is the opposite of b. That 1 is my a. So then I do my product. I'm multiplying 7 plus 3i times 7 minus 3i. What do y'all notice about that? They're conjugates. So I should be able to just use that formula, 49 minus 9i squared. What does that I squared make that negative 9? Positive 9. Which gives me 58. Again, it's a whole number. I wanted a fraction, put it over 1. What is that 58? C, and that 1 is still my A. So my equation in standard form would just be x squared minus 14x plus 58 equals 0. Y'all good? Any questions? Now we're going to move on to our quadratic inequalities, okay, where we're going to graph it. So we've already talked about how do you find the vertex algebraically with the negative b over 2a, then you plug it in and do all of that. We've already done that. I'm not going to make you do it now. You've got the graphing calculator. You can use it on this portion of the test, get your vertex from the calculator, okay? So if I have y is less than negative x squared minus 2x minus 1, I'm going to graph that like it were an equal sign. Okay, but you still have to, when we graph it, we still have to consider dash versus solid lines because those are our boundaries and we need to know if it's equal to or not equal to. Okay, so in your calculator, go to the scratch pad, hit that calculator button again, and you get the graph. Okay, so I'm going to graph negative x squared minus 2x minus 1. Okay, now I want to see a table. Yes, you can get your vertex from the calculator, but I want to see a table. So what should my vertex be? Negative 1, 0. So I'm going to go ahead and do Control T on my calculator and make sure that around that negative 1, 0, my y values are repeating because it's symmetric. So in the middle of my table, I have negative 1, 0. Then I'm still going to do 2 above and 2 below. So I'll have negative 2, negative 1, negative 3, negative 4. And then I have 0, negative 1, and 1, negative 4. I'm going to plot those points, then I'm going to analyze and see, am I doing a dashed or solid line? So my inequality is less than. So if it's less than or greater than, those are dashed boundaries. If it's less than or equal to, greater than or equal to, those are solid boundaries. Okay, so I'm going to have a dashed boundary for this parabola. Now, in order to figure out where we shade, because with inequalities, it's a boundary and you have a shaded region. Your shaded region is your solution area. Now, with quadratics, we're going to use a test point. If at all possible, I'm using 0, 0 for my test point because that makes the math super simple. Okay? So I would look and I would have my y is 0 is less than, my x's all go away because it's 0. So 0 is less than negative 1. Is that true? No, that's not true. So because it's not true, I am not shading where my 0, 0 is. Okay, so you see how you have two parts. You've got outside the parabola and you've got inside. That 0, 0 is on the outside. It's not true, so I'm shading on the inside. I want to see you do a test point. If you don't have a graphing calculator at home, there are graphing calculators online, Desmos.com. There's a graphing calculator app, Calculate 84. The buttons are just a little bit different because it's an 84 instead of an Inspire. Okay, so there's that out there. But if you know how to solve for the vertex using the negative b over 2a, and then plugging that in, there's really no reason you couldn't do this even without the calculator. So that's the reason you've got to understand how to shade using that test point. Okay? Y'all good with that? Okay. So then that was just one quadratic inequality. Now we're going to do a system of quadratic inequalities. So you're going to have a table for both of those quadratic inequalities. So I'm going to go ahead and clear my calculator and get back to the graph. And I'm going to plug in my negative x squared plus 3. And I'm going to get that table before I move on to the next one. Okay? So I graphed that negative x squared plus 3. What should my vertex be? 0, 3. So I'm going to look at my table and make sure 0, 3 is my vertex, which it is. So I'm going to do my first table with 0, 3 in the middle. Then I'm going to have negative 1, 2, negative 2, negative 1. And then 1, 2, and 2, negative 1. I'm going to go ahead, clear it, since I'm already on the calculator, and get the table for my second quadratic inequality. So I'm going to have x squared plus 2x minus 3. Enter. Now what should be my vertex? If you can't tell from the graph, look, you know that it's in the negatives. So if you look, you'll notice negative 1, negative 4. It starts repeating around that. So for my second table, negative 1, negative 4 will be in the middle because that's my vertex. Then I've got negative 2, negative 3, negative 3, 0, 0, negative 3, and 1, 0. So I'm going to graph my first parabola. My first parabola was less than. Is that going to be dashed or solid? Dashed. Make sure when you're graphing it, I can tell if it's dashed or not. Okay, and I'm going to lightly shade. I'm going to find my test point and figure out where I should lightly shade. So again, I'm going to use 0, 0. So that would make it 0 is less than 3. Y'all see how I'm getting that? Y'all sure? Okay. So is 0 less than 3? Yes. So I'm going to shade where that 0, 0 is. So that section is also inside the parabola. Then I need to graph my second parabola, do a second test point. Now that one is greater than or equal to, so will that be dashed or solid? Solid. If you have to use different colors so you to see it, that's fine too. And I can still use 0, 0. The only time you don't use 0, 0 is if that happens to be a point on the graph. So then for my second inequality, 0 will be greater than or equal to negative 3. Is that true? Yes. So I would shade where that 0, 0 is again. So that is also on the inside of this parabola. when you have a system, you're trying to see where they overlap. So my overlapped region is that middle section right here. When you are graphing it, if you shade both like I just did, make sure that you make that overlapped region darker like I just did. Or if you can do it in your head and you can see where you're graphing, you don't have to do this shade, and then shade the middle. You can just show me where they overlap. I'm okay with either one, as long as I understand where the overlapped region is on your paper. Okay? Any questions on that? Okay. So that's all we need the graphing calculator for. That's it. Okay? Everything else is back to normal. This is our last section. And this is where we're going to be solving the quadratic inequality algebraically. Okay? So we're going to write and solve by replacing the inequality sign with your equal sign. And we are going to factor. Okay? We're going to be factoring those to get the x values, which are your solutions, which are your x-intercepts. Those are called the critical values. Okay? So your x-intercepts are the critical values for this. You're not going to draw a number line because I already have it there. That is your x-axis. So you're going to plot your critical values, the x values you solve for, on the number line. Now if it's less than or greater than, it's going to be an open circle. If it's equal to, it will be closed. Okay? Those are going to create intervals. So once you plot your two critical values, or however many critical values you have, you're going to look at your leading coefficient. Okay? Your leading coefficient determines the right behavior of your graph. Now we're dealing with a quadratic, so that's a parabola. The right side does exactly what the left side does. They either both open up or they both open down. But when we get to quadratics, or not quadratics, cubic functions or higher, you're going to have a different end behavior than what a parabola does. Okay, so your leading coefficient always determines the right side of your graph. So if my A is positive, the right side of my graph is going up. If my A is negative, it's going to go down. Okay, so knowing that it determines the right end behavior, we're going to start from the right and go left, which is backwards of what you would ever want to do. Okay, but we're going to start right and we're going to alternate signs from those critical values. Okay, so if I have x squared minus 3x minus 4 is less than 0, I'm going to replace that inequality with an equal. So it's equal to 0. I can now factor and solve it. Okay, now this is a basic x squared, so I should be able to look at that and say what factors of 4 are going to give me a negative 3. Well, this 4 is negative, so does that tell me I'm going to have the same or opposite signs? Opposite. One's going to be plus, one's going to be minus. My factors of 4 that give me a 3 would be what? 1 and 4. Which one's going to be negative? The 4. Remember, your largest factor takes the sign of the middle. Okay? So then I'm able to say x plus 1 equals 0, x minus 4 equals 0. So x will equal negative 1 and x will equal 4. So those are my two critical values. I've got negative 1 and I've got 4 on my number line. Now my inequality is just less than. So I'm going to have open circles. Okay? Now that I have this, I'm going to look at my leading coefficient. It's positive. So from the right side, I'm going to have a positive, then I'll alternate negative, then positive again. Okay? Then you're going to shade. If it's less than or equal to, you shade the negatives. If it's greater than or equal to, you're going to shade your positives. So this was less than, so I'm shading my negative interval, which is in the middle. So this is basically telling me that I have a positive A, so I know that it opens up. If I were to graph this, it would look something like that, and it would be shaded in the middle. Okay, you don't have to do what I just did in pencil. I'm just letting you visualize what this is really representing. Okay, so once you get your shading down, you've got to write the solution in interval notation, and then you're going to describe it. And I'm looking for specific things when you describe it. So my interval is going to be so it's in between -1 and 4, but it's not including -1 and 4. So there's my parentheses. So there's my interval. Now I want to see what direction it opens, where it crosses the x-axis, what type of boundary I would have, dashed or solid, and where it's shaded. Okay, so on your notes and your homework, we're writing that. On your test, I have blanks. Okay, I just didn't put the blanks on here. So I know that my graph opens where? Okay, the graph opens up and it crosses the x-axis where? At -1, 0 and 4, 0. It has what type of boundary, dashed or solid? It has a dashed boundary. And shaded inside. If you want to put inside the parabola, you can, but I'm good with just it's shaded inside or it's shaded on the outside. Okay? So when you are doing your homework, you've got to include all 4 aspects. Where does it open, up or down? Where does it cross the x-axis as your ordered pairs for your x-intercepts? Dashed or solid, and where is it shaded? Okay? So this next problem, x squared plus 4x minus 32 is greater than or equal to 0. I take it and set it equal to 0 so that I can solve it. That 32 is negative. Are they going to be the same or different? Okay, what factors of 32 are going to give me a 4? 8 and 4. Which one's positive? So the 4 is negative. So x plus 8 equals 0. X minus 4 equals 0. X will equal -8 and x will equal 4. So those are my critical values. Are they going to be open or closed circles? Closed because it's equal to. I'm going to look at my leading coefficient. It's positive, so I start on the right side and alternate those intervals. Now it's greater than or equal to, so I'm going to shade where? The positives or the negative? Positives. Greater than, I'm always shading positive. So I'm going to shade wherever I've labeled a positive, so that happens to be on the outside. Okay? So my interval for this graph would be -∞ to -8 with a bracket and bracket 4 to +∞. Remember, you have to have the union in the middle. Then we're going to describe it. I don't have enough space for all of that, so I'm going to put shorthand. Where does it open? Okay. Crosses where? Okay. Dashed or solid boundary? shaded where? Outside or inside?
Outside.
Are good? Any questions? Okay, last example. Negative x squared minus 4x minus 4. We're going to set that equal to 0. So what do I need to do? Take a negative out for my GCF. Then I need to factor it. That last 4 is positive, so they're the same sign. They're both positive. Factors of 4 to give me 4. 2 and 2. What happens there? It's going to end up being a double solution. So x plus 2 equals 0. I only have to do it once. X equals negative 2. That's going to be my double solution. Remember, you've got to label the double solution. When it is a double solution, that is the only part that touches the x-axis. Okay? Does it cross or does it touch? It touches, because remember, that's really what your vertex is. When you have a double solution, that's the vertex. So it's not going to cross at negative 2, because then you would have to have a second x-intercept. So I'm going to have negative 2 as my critical value. Is it going to be an open or closed circle? Closed. So really what that looks like is I have a negative leading coefficient, so it is just going down. It would look like that. Okay? Again, you don't have to draw that, but I'm just letting you visualize it. Now, when you have a double solution, I do not alternate negative, positive. It bounces back, so it just stays negative, negative. You do not alternate signs for a double solution. Okay? Now, my inequality, though, is greater than. Greater than, I shade the positives, right? I have no positives on my number line. So this would technically be the outsides. It's going to be shaded on the inside. Okay? So when you have double solutions, those are going to be the only ones where you really have to think about that. Okay? So I had both of these negative because my leading coefficient is negative, but because my inequality is greater than, I would have to shade the positives, which aren't there. It would be shaded on the inside. Okay? So my interval is only going to be negative 2. It opens down. Now, I'm not going to say it crosses at negative 2. It touches the x-axis at negative 2, 0 and bounces off. Would it be dashed or solid?
Solid.
A solid boundary. And it's shaded in the middle. Or inside. It's shaded inside the parabola. Yes.
How do you know that on the second one it opens up?
So if your A is positive, it opens up. If it's negative, it opens down. Any other questions? Y'all are good? Okay.